Thank you. We'll just put that there. So the irony of my trip is it took me 3 hours from Blaine, but I live in Seattle. It took me 2 hours to get to Blaine from Seattle. So put that math together. So thank you all for being patient with me today. I am also very much glad I made it. So I love speaking here. I love this group. You all are awesome. Great setting too. I mean, good heavens. Great view there. And so hopefully we can learn and grow a little bit together. What I want to talk about is essentially we're going to go through some of the things that we think about when we think about our CI processes, and then how those things aren't necessarily changing, but yet they really are, right? With our development flows today, we have things that are amplifying those processes, putting a lot more stress on those processes. So tell me if you've seen this, or maybe you've actually posted this onto your local Slack. The CI is slow again. Maybe you've even seen it this week, right? You're sitting there, you're waiting for it to finish. And you go ahead, you're responsible for that CI process. You're like, all right, let me go see what's going on. You check out the workflow and the build, and it's like, yeah, 12 minutes. It's about right. It's what it's always done. Which was fine when you were committing maybe a few times a day. But how many times are our agents committing a day? Maybe even an hour, right? 12 minutes was fine before, but not so much these days. So what I want to do is talk through some of the ideas of what we can look for inside of our processes to make it that much more efficient for agents. These numbers here, 46% of code is now AI generated. This comes from actually GitHub. They're talking about their Copilot project. And of those, I like to talk loud, so that's going to be really loud for this microphone. Am I loud enough if I go here? No. Okay. Then I'll just talk quieter here. I just get excited is the problem. 1.2 million PRs per month. Again, building on Copilot using just the coding agent alone. So the problem with that 12-minute duration isn't so much that it's 12 minutes, but what's happening in those 12 minutes. And so when we take those 12 minutes and we break it down, we see that more than half is building of infrastructure. Queuing it, setup, dependencies, all of that isn't unique to that particular commit that you had. The rest of this stuff, the testing, yeah, that's probably new. The build, yeah, your code changed. That's new. But all this here is stuff where we can make it that much more efficient. So the number, as far as that time it takes, didn't change. But the problem has, because now that we have that many more commits and that many more runs of our CI process, 12 minutes now is a major bottleneck. So now our flow is that we, as developers, we have agents at our disposal. Our agents are writing code, they're opening PRs, they're kicking off a CI pipeline, which the process has to wait for that to get done before we can commit, before we can push those changes into production. So a slow CI means that if something happens, say if you have a bug, say if you have a customer that reported a problem, or you need to get a feature out super fast, is still waiting on that CI pipeline. So there's 3 things killing your pipeline today. First is that queue time. Runners, they're sized for human-paced development, right? We have runners that are built inside of GitHub Actions, and I'm going to be talking about GitHub Actions mainly because, well, let me ask. Who's using GitHub Actions? Who's using something else? Okay, what else are we using? Okay?
AWS Copilot.
Okay?
Circle CI.
Circle CI. Okay. All of these principles can relate to those processes, but I'm going to use GitHub Actions as the example. So in this case here, for GitHub Actions, GitHub has its own runners, but then you can also have hosted runners, right? You got Blacksmith, you got Depot, you could have something else where you can hand off the process to them, and that can knock down your queue times a little bit. You have the cold starts. When you're firing up those runners, that virtual machine So a runner inside of a CI process is essentially a virtual machine running on that system's infrastructure. And so in this case here, if you have a cold start, you have to have time for that machine to load, for it to load its own dependencies and then load your stuff. And then the network overhead, what's happening when you are taking your dependencies, taking your image builds, taking all of those things and loading them into their system, there's still a network connection that happens in there. So that network overhead is also one of those pieces that's costing you a little bit of time. So queue time. Interesting case study about queue time. SeatGeek actually had a story, a blog post that they wrote. I have a link to that. The link's here, but also I'll have a link at the end on the ending slide. Fascinating way that they took their queue time from 3 minutes down to 4 seconds. They were able to do this by migrating their whole CI process to Kubernetes and then using auto-scaling there. So they auto-scaled their clusters so that they could spin up when they needed it, spin down when they didn't. And so they were able to take their queuing process all the way down to 4 seconds. Something to keep in mind, they thought differently. They thought outside of the box that they were in and thought, okay, now we can put our process and move it over into an auto-scaling situation. Then there's that startup tax. For here, GitHub Actions, back in August of 2025, they took this into account. This is, again, coming from one of their blog posts back in December. They were able to take the cold start that they had of their virtual machines inside their infrastructure. Now, I know that the press has been, and I don't know, who's had issues with GitHub Actions? Okay, only one, that's fine. I know I'd heard a few months ago it was pretty rocky. They were kind of falling over a lot. They weren't going very well. But in December, they had a blog post where they took their cold starts by making them more efficient from 30 to 45 seconds down to under 5 seconds, essentially trying to help you as a customer be that much more efficient. The way they were able to do this is essentially they were able to cache the resources that they needed, but then also in their taking their cold starts so that they could have certain elements in those startings, they would be cached. Right. All right, so digging into each of those different categories inside of those 12 minutes that we were looking at before. Queue time, setup, dependencies, build, and test. As we mentioned before, the actual work is only about 35%, right? All the rest is just infrastructure overhead, which is the point I made there as well. So what I want to do now is actually we're going to jump out of this. I was trying to think of a way to illustrate this in a realistic way. And as we do nowadays, I started chatting with my friend Claude. And I was like, all right, how can we illustrate this? How can we show this particular breakdown of how things load and what we can do? And we came up with this, very small. Here we go. A CI time budget analyzer. And what it does is I'm able to take a look at one of these GitHub repos. And we're going to look at the breakdown inside of one of these repos and see how they run. Now, in this particular situation, because I just showed up, let's hope it works on the first try. If it doesn't, then we get to play with some tokens and things. All right, so in this case here, if we took my CI performance demo, sure didn't. Okay, just a second. We are going to disconnect the screen because I don't want you to see my keys. I'm going to put my microphone down just a second. Stay, good. All right, just a moment. So here, what I'm doing is I'm gonna go grab an access token. Actually, I'm not gonna grab an access token. I need the Wi-Fi. Done. All right, so I'm gonna see if this loads. Yeah, buddy, all right, sweet. Okay. Go here. Oh. I just want Northeastern University to know that I caught that microphone before it fell. Just saying. All right, so here now I have a project that I took that's my own, where I wanted it to at least have some numbers. And so I clicked on my particular project, and I'm going to look at it with, I believe, this is going to be with caching. Okay. And so my average duration for the last 10 runs, because of this project I only ran it 10 times, was about 30 seconds. The P95 duration is not 30 seconds. Now, we'll look at it for a second. You'll see where it happened, even though this repo, this project is being cached. What's nice about this is it lets you know that reason why you want to know that P95 is because when you're running these processes, when you're running any process, do you think about that average time that you're sitting there? Like when you're running a process and you're like, oh yeah, the average time, it's this. Or do you remember that time when it took 10 minutes when it was supposed to take 2? Right? You remember that P95 time. That's the time that people reach out and say, hey, this is busted. So it's good to keep in mind, okay, let's understand that the average is doing pretty good, but if we're having spikes, and this is what the spike is, let's check out those spike times. So in our case here, we see that setup in a init is kind of the big deal. I can see in my project here, if I look at my 10 runs that I have, all successful, all pretty quick until it comes down to here. Why? That's when it was caching. It grabbed everything and was caching on this first try, and then after that, took the caching into play. And so that was nice, made it a little bit faster. So we can see in this case here, all right, I did an okay job in this demo, but demos are fun only when you're looking at real life stuff. So let's go look at a real repo. And I believe the one that I wanted to show there was one that I saw the other night that I was like, yeah, that'll be a perfect one to show everybody. And I was gonna line it all up before I walked on stage today. But the traffic on Highway 99 said nope. So here, yeah, this one's good because it has a lot of variety of what's going on. So I'm looking at the next project, Next.js from Vercel. And in here, I can see all the branches that have different. We can look at each one, but in this particular case, I'm just going to look at trigger release. And we can see that the average duration is about a minute or so, but that 4 minutes there, that's our P95. I want to keep that in mind. But then also, okay, our success rate. Look, our success rate's 78% of the time. I mean, it can be okay, but that seems to me a lot of failing. And so, but we can take a look at each one of those steps and say, all right, so the deployment is what's taking time. The setup in a init, that's also taking time, 25 seconds. And we can come down here and see our projects and see our different runs. And I can see the failures of each of the runs, which branch it's on. So yeah, we're on the Canary branch here. And then drill into it if we want to. I can say, take a look, and then go look at why, and look at that different process. So the hope with this type of tool is thinking about what is happening. Thinking about, okay, in this run, I have this run here. I know that this one took a total duration of 1 minute and 15 seconds, or I guess 1 minute and 12 seconds on this particular workflow. And so, but looking at that 1 minute and 12 seconds, what is actually happening? And so hopefully the visualization of what's happening on that 1 minute and 15 seconds, we can see that, all right, my overhead is about 60% on this one, on setup, and some other things. And so keeping in mind, looking at your own repos, if you look at those numbers, you can see, okay, where can I make things a little bit more efficient in my processing, or in my CI process. All right, this was in case that didn't load, right? If the internet was bad, or if I was bad. And so in that case, we'll skip over these. So diagnosing our projects here. So finding a baseline in your budget. you want to make sure that you're not looking at a single run. You want to look at a group of runs. So in my case, in my demo, I had at least 10. But in your case, you're probably running a lot more processes. So looking at about 10 to 25 makes a lot more sense, because then you can see the averages and you'll get a more realistic average plus more realistic spikes. You'll get the more realistic idea of what's happening across the board rather than just a single time or a single run in time. You want to find that fat tail, because those are the ones we remember. We remember the spikes. We remember that P95 situation. And then see if the average time and the P95 time is the same. If they're always up there, that's a problem. So you want to see if things are spiky or more consistent. And then when you're looking at how to best attack this, the strategy that I recommend that has helped me in the past is find the things that are the most high impact, but yet the lowest amount of effort to give you that momentum. You want to have that momentum to say, okay, we tried some changes, and here are the changes we did, and oh, they actually worked. And so let's move on to the next one. Because if you look at the hardest one to fix, you're going to get stuck and then spin your wheels on it and then not make any progress. In this case here, this is another visualization of coming up the fact of, yes, that's our average build time, but really the ones we think about are those builds that are more of the longer tail things. As I mentioned before, you want to go for the highest leverage activities first, whether it's the easiest fix that you can find that have the highest impact. And so there's 5 fixes that you can look at that we'll talk about here. So dependency caching, auto-scaling runners, parallelization with testing, Docker layer caching, and then eliminate unnecessary work. So dependency caching, in this case here, you have a lot of dependencies. Say if you're running like a Python application, you're going to need pip. You're going to need other package managers or other tools that you'll always need, right? Those dependencies you want to make sure you have cached inside of your CI pipeline, your CI process. That way, when you're running your processes, it's not doing that work that it has to do every time. It needs for every single build. You're not doing those or grabbing those dependencies every single time. The auto-scaling. This goes back to the SeatGeek idea. The SeatGeek idea where they were able to track the progress of their CI processes and then load new runners when they need them and auto-scale their particular clusters that each have a runner running inside of them. Again, they have more details inside their blog post, and it's a fascinating read. With testing, running or having parallelized tests make things a lot more efficient, especially if you have multiple processors inside of your CI infrastructure. And so in that case here, just figuring out ways to separate those tests. That's really the trick there, is how to efficiently separate the tests to keep them parallelized so they're not running into each other, but then also so that you're testing things that don't conflict. Now with Docker layer caching, what's fascinating with Docker is when you start digging into the process of how the Docker files are run, how the fact that it's running it runs synchronously, so that if you're changing something, if you have a change in your Docker file that's on line 3, it has to reprocess everything from line 3 down. And so when you want to make those changes, you put those things that you're changing a lot towards the bottom of your Docker file, things that you're keeping the same, things like loading in your package managers, those types of things, loading in the languages, the runtimes, you want to keep those towards the top. And then the last thing I was talking about, eliminating unnecessary work. Path filtering, making sure that changes in particular files, like the fact that if all of your YAML files or your documentation is in one directory, then you can make sure that those directories aren't triggering off your CI process when they don't need to be, right? If you don't have any like sample code in your documentation, you're not want to run tests on all the code. But if you do have samples in your documentation, then you should run tests on that code, because how annoying is that? To look at someone's documentation with sample code and then the sample code doesn't even work, right? He's been there. So just like me. And then looking at the processes that you're running, the most run pipelines. Yeah, so you want to look at those processes, like look at your pipelines, audit them regularly. It's just like anything else. Is it really doing everything you want it to do? Or is it doing stuff that you, on a feature that you had before, but you've moved another direction and you still have the CI process running? So just make sure that the CI process is actually running on the code that you care about the most. So you optimize the input, which means the agents are helping us write more code. The part we haven't optimized, or that I'm arguing right today or presenting today, is have we optimized that feedback loop? Have we optimized the process where we run our CI processes? The reason why we want to be doing this is why, right? Why did we do CI in the first place? Why are we having automated testing? Because the DORA report back in 2024 talked about successful organizations, successful companies, successful projects had more frequent deployments, things that were automated so that we could write more code, write more features faster, fix bugs faster by having more deployments, having faster lead times, and then lower failure rates. Just an idea to take into account about the overhead, the time things run. If we're only running a few builds a day, 4 minutes isn't a problem. But if you're running 100 builds a day, that turns into a problem. If you're running even more than that, if your agents are pushing forth a lot of these changes, you want to be thinking about the time that this CI process is taking. So, your homework this week, when you go back to work, is look at your past 25 runs. Break down where that time actually happens. What happens inside of your runs? And is there something in there that you could make more efficient today? You could even use the tool that I have, that I built. I'll give you the link again on this, the ending slide. But then find that worst job, the one that's getting everybody's attention, and think about how can I make that particular situation not happen again. And then ship one fix to fix that P95 situation. And remember, make it an easy one. Make it a thing that you're like, oh wait, I know what I can do there. And then make that fix so that you can say, all right, now let's really dig into this thing and make it that much more efficient. So agentic development changed how fast our teams write code. So let's make sure our pipelines can keep up. Here's the, probably, let me see. Can we make Google Slides that much faster? Or, nope. So my apologies if you can't see it. Here's a link to the budget analyzer project that I made. If you have any changes that you want to make to it, please feel free to open up a pull request. I'd be happy to review it and add it to the code there. The DORA report that I mentioned before on Dora.dev, but the reason why I use 2024 is because that's the last time they talked about the breaking down the importance of what success looks like on the different organizations. And then the SeatGeek CI Runner blog post. Fascinating stuff about how they were able to take their processes and auto-scale them. All right. Thanks, y'all. Yeah.
Hold on, let me get it.
It'll give me a second to give a drink.
Turn down. 1, 2, 3.
Green
Kind of like
good,
flashing
red
green
bad.
and stuff. No battery.
Yeah, I think.
Oh, look, I was gonna bring this one over and then just we could do the whole
Green good,
this thing.
red bad. Just remember that.
Yeah, so I
Yeah.
think one of the problems is the agents, the fact that they pull so many changes, maybe not the pipeline. Like, if I just wrote the code myself, I would usually run tests locally. So is there, I guess if there is some kind of environment in which the agent runs, that they can also have run the test locally before pushing to CI. And I mean, the bigger problem is still like if you do agile, you want to build, measure, learn loop. So like you need to measure whether your changes actually make like real value for your company, regardless of how well they run. So I would imagine that's even slower. Or it like doesn't matter how fast you ship code, you should like slow down and wait for feedback from customers. Right?
Absolutely. I agree. I think the thing what the agents are doing is I don't know if they're changing how they're not changing the whole process. They're just making writing code at least the amount of code faster. But us as developers, us as engineers, we still need to be thinking through the problems, because if we don't explain or give it a good enough prompt, that agent isn't going to build what we want it to build. And so in the case there, you were talking about, don't we also want to slow things down, have local tests, and then before it even gets to the CI process, right? I would completely agree. And in that case there, that makes those situations, we wanted to have local tests anyway when we're writing codes by hand, right? So we still have those tests that we still run, and then we kick it up to CI. So yeah, I would absolutely agree that we want our agents to have tests, or at least even have humans step in and say, okay, great, you wrote that, it builds this, it's doing this, but I'm gonna test it, I'm gonna check your work, because you wanna make sure that it's actually writing what we want it to write. So I agree.
Any other questions?
Do you have any experience with any tool that is able to understand, select, I would say, subset of tests according to the change that have been made? It is not just path filtering.
There are, I know that a lot of platforms that are in the CI space, things that are providing hosted runners like Blacksmith and Depot, they are able to do similar types of filtering. I don't know the details of those though, but those are the two that kind of come to mind to look into. But past that, I probably shouldn't be the one that says much past that. So,
If you're interested in also triggering only a set of tests depending on what file you change, is that kind of what you're looking for?
Yeah.
In GitHub Actions, there's two really good actions. There's one called PJ change files. That's the one that you basically can send a list of files or paths, and it will essentially build a matrix depending on which file you touch. So that one is really helpful when you have like a mono repo and you want to run only one piece of the test, for example, because you only changed this piece. So that's something you could use. There's also another one called paths filter, which is also the same concept.
But filtering is not dynamic. You have this specific.
Yeah, that's the only problem. You need to kind of like specify, have some sort of matrix where you define the jobs. Yeah.
Thank you.
yeah.
Yeah, I have a question about your personal opinion, I guess.
Sure.
So there is like two teams usually. One team prefer more tests on a feature branch before merging, like running full test suite, like end-to-end test, everything, and it's super slow. You usually cannot do this under 12 minutes anyway, like
Right.
it's always like 40 minutes or so. And another group of people usually arguing, oh, we don't need all of this, we will run test anyway after we merge things to the main. Right, so where you lean towards more?
Me personally, we want things fast, but we want things right. And so I think you should be testing all the things. finding the principles I was talking about today was thinking more of how can we make the other things more efficient so that the things that are important, like testing, even end-to-end tests that take a while, are what's taking the time, not building the infrastructure. So that's my thoughts.
Any other questions? You? Okay.
I also want to ask for a personal opinion because, well, I have a background that I think lots of people work with GitHub. I work on the totally opposite spectrum. In the past few years, I work in internal GitLab, so we build our registries and all the things internally.
Mm-hmm.
I face most of the problem you face, and what we have dealt with them is like, well, Kubernetes with GitLab, and we have our own internal clusters, so all the images and all the dependencies we have access and all those stored, so everything looks a little bit like local. But if for developers usually use GitHub, it's more about the matter of flavor of the infrastructure at this time, right? So do you really have options to modify things that can proceed on the local spectrum?
So you're saying the developers using GitHub don't have the opportunity to modify things on a local spectrum because with GitLab having the hosted version, the local version of GitLab, right, inside your organization, you're able to do those things. Yeah. GitLab is, in fact, I think SeatGeek is using GitLab. The SeatGeek example that I was talking about here with their auto-scaling infrastructure. So yeah, being able to make those changes, it sounds like it has a lot of abilities to be more flexible in these situations.
Okay. One question in the back.
Yep.
So my question is do you recommend having or setting up agents specifically overseeing the pipeline and making autonomous decisions to improve the pipeline itself? It seems like everything that you have just mentioned, something that repetitive, someone that can be automated by machine. So would like to have your thoughts.
I think having an agent being in charge of your CI processes is as good as long as you know how to best use your agents. Not just handing it off to the agent, but having the agent be the assistant on that. Because in fact, there was a pull request that came in on this project where I looked at it and I thought it looked great. I ran some tests, it was fine. But then I had an agent look at it and the agent was like, well, what about this, this, and this? So together, I think it works well. So I think having that automated agent assistant in those situations it can be super powerful. But I also think humans should definitely still be involved. Yeah.
About the reusing tests, it just came to my mind. I think you, Carmelo, you asked that. There is this platform called Bazel. It's a product that Google created for testing. So I had experience with that using remote caching, where basically your entire CI can share the same caching, and basically you run a test with Bazel, and you push it to the cache that is shared with all the pipelines. And essentially, if the pipeline detects that, oh, this test has been run with the exact same code, it won't run. So maybe that's another way you could improve your testing as well. I work in a system that it was taking 60 to 65 minutes to run 65 different unit tests and integration tests and a lot of stuff. And I think we took it down to 15 minutes using this strategy. So maybe that would be something good to check.
Thank you.
Any other questions? If not, thank you so much for coming, and thank you, Scott.
Thank you all.